As human beings evolved, so did their ideas. And one that stood the test of time is the gearbox. It's been around for literally thousands of years, and it's come a long way. The most basic gear is called a rack. It's used to move things back and forth. Now, if you bend it upward so the teeth are in the inside, you get what's called a ring gear. Bending it downward turns it inside out, you get a pinion. Circular gears are generally used to spin a drive shaft. Now, the trouble with ring gears is there's nowhere to put a drive shaft. They're empty in the middle. Pinions, on the other hand, are solid, so they're easier to deal with. And if you just put two of them together, you've got yourself what's called a parallel axis drive. Easily the most common gearbox design on the planet because it's so simple. Now, just like any gearbox, you turn the input shaft, or you use a motor, and the gearbox does three different things with the output shaft. Changes the speed, that's how fast it turns. Changes its torque, that's how hard it twists. And it changes its position, it shifts it by an offset distance. Now, speed multiplied by torque gives power. And according to Newton, energy doesn't just rain from the sky. Whatever power you put in, that's exactly what you're going to get out. So if speed goes down, then torque goes up, and by the same amount. It's called the gear ratio. Now, gearboxes are used all over the place. They're used in cars, tools, windmills, medical devices, pretty much anything that moves on its own. So there are a lot of different things that might be important. In any case, it needs to be strong so it doesn't just blow up when you hit the gas. Of course, you can always just make it bigger, but usually space and cost are also an issue. Adding a few together will make it stronger. Save a few gears by putting them in a circle. But then there's too many output shafts. Add a ring gear and it becomes the output. Now the input and output are both right in the middle. This can be really handy because you don't always want an offset, but you do have to find a way to put a shaft on the ring. To get around it, the ring is locked down and those bigger gears are put on a plate. That makes the plate spin. This is called a planetary drive because it looks kind of like a bunch of planets orbiting a sun. It's used a lot because the shafts line right up and all those planets make it strong. So what do we got? Parallel axis drives are simple with low ratios and offset axes. Planetary are strong and have a common axis. I'll spare you the math, but all those teeth in the ring gear make the planets spin more, and that increases the ratio. Of course, spinning also causes friction, and a funny thing about gears, they like to push away from each other. Since the planets are getting pushed in two directions, they vibrate, and that can get loud when they're moving fast. There is another kind of gearbox that's a lot like a planetary, but instead of a ring gear, it has another carrier. That takes care of the vibration and the extra friction. In fact, the planets slow right down, so you also lose some of the ratio. At first glance, it's hard to imagine how it could work. Planets all have two axes, and one of them is even in the center of the gear. Kind of makes you think something complicated's going on. But it's really quite simple. Let's take a look at how it works. This setup is called a 4-bar linkage. It's plain to see that the little bar on the end moves around in a circle. Kind of like a planet, it just doesn't spin. You can have more than one, that's no big deal. Turn them into circles, easier to make. Trade in the bars for planet gears, throw in a sun, and you got yourself a proper gearbox. It's called an Orbitless drive, which looks a whole lot like a planetary, and it kind of works like one. The drive shafts line up, and it's strong because of all the planets. There's no ring gear, but there's nothing wrong with that. Ring gears are not the cheapest thing to make. Between the three, the Orbitless is the most recent of the bunch, so folks are still working out what to do with it. It's a bit of a compromise between the other two, strong like a planetary, but without any idler gears, Those are the ones that engage in two spots. When gears spin, mesh, and vibrate, they make a bunch of noise. So the Orbitless is the quietest of the bunch, and that's probably how it's going to get used. You see, gears often get added together to get a higher ratio. The first in line moves the fastest, so it makes the most noise. As long as you make that one Orbitless, the rest could be anything, and the whole thing will be quiet. Parallel axis will get you an offset, and planetary if you need higher strength. Parallel axis, planetary, and Orbitless gears. They may not make the world go round, but they do move everything inside of it.